Hello, we are discussing about GATE 2004 ECE paper and the topic we are discussing is electron devices. This is fourth 2-mark question came in 2004. Consider the following statements. Statement 1. The threshold voltage of a mass capacitor decreases with increase in gate oxide thickness. Statement 2. The threshold voltage Vt of a mass capacitor decreases with increase in substrate doping concentration. Which one out of the following is correct? S1 is false, S2 is true. B. Both S1 and S2 are true. C. S1 is true, S2 is false. D. Both S1 and S2 are false. Question is related to mass capacitor and the threshold voltage of that mass capacitor. What happens to threshold voltage if gate oxide thickness is increases? What happens to threshold voltage if we increase the substrate doping concentration? Based on that one, if we know these two things, we can solve this question. Correct answer for this one is D. Both statement 1 and statement 2 are false. We will see the details now. First look at the statement 1. Threshold voltage of a mass capacitor decreases with increase in gate oxide thickness. If gate oxide thickness increases, at that time threshold voltage reduces, whether it is true or false. First we will see how a mass capacitor is formed. A simple mass capacitor is formed with gate, silicon dioxide and substrate. Substrate we are taking with p-type substrate. Substrate is of semiconductor and previously gate is made up of metal, that is aluminum. That's why initially MOS abbreviation came. Gate is made up of aluminum, that is metal, and silicon dioxide is nothing but oxide, and substrate is of semiconductor. So MOS, metal oxide semiconductor. Whereas this mass capacitor simply it acts as parallel plate capacitor where gate and substrate are going to be two parallel plates. This is one parallel plate, this is second, and distance between these two plates is nothing but oxide thickness. So TOX, thickness of gate oxide layer, that is SiO2 layer. So general equation for the capacitance is Q by V, where C is proportional to 1 by V. So capacitance depends on voltage. Okay, so C is inversely proportional to V, and from this equation, from this one, mass capacitor act as parallel plate capacitor. Parallel plate capacitor equation is epsilon A by D, where D is nothing but distance between the plates. Here we can write TOX, distance between the plates, that is oxide thickness. From this one, capacitance is proportional to 1 by TOX. So general equation is capacitance proportional to 1 by V, and from this one capacitance proportional to 1 by TOX. So V is proportional to TOX. So as TOX increases, voltage increases. As TOX reduces, voltage reduces. But the given statement is threshold voltage Vt of a mass capacitor decreases with increase in gate oxide thickness. So it is false. Statement 1 is false because as TOX increases, V has to increase. Next, consider the second statement. The threshold voltage of a mass capacitor decreases with increase in substrate doping concentration. If we increase the substrate doping concentration, then threshold voltage has to increase. Whether it is right or wrong, we will see now. As we know, mass capacitor is made up of gate, oxide and substrate, and here we are going with this is substrate. The example we are taking is p-type substrate. P-type substrate is nothing but holes are majority carriers and minority carriers are electrons. Threshold voltage, definition of threshold voltage is nothing but minimum amount of gate voltage to be applied such that a channel is formed. So p-type substrate is nothing but we are dealing with n-channel MOSFET. N-channel MOSFET will be consisting of the channel consisting of electrons. So the channel is nothing but region near this SiO2 layer. So this area is going to be just below SiO2 layer. The region is going to be treated as channel. and channel should be consisting of electrons for p-type substrate. So the channel is consisting of electrons, that is nothing but minority carriers of substrate. So what happens to minority carriers if doping increases? That we will see. P-type substrate majority carriers is Na, acceptor concentration, that is nothing but substrate doping concentration. If Na increases, what happens to minority carriers? So that we can say whether threshold voltage has to be applied more or less. As Na increases, minority carriers in the substrate reduces. As Na increases, minority carriers in the substrate reduces. So whenever acceptor concentration of p-type substrate is going to be increases, by that time minority carriers, that is electrons in the p-type substrate, reduces. This is because of mass action law. Mass action law states that under equilibrium condition, the product of free electron concentration and hole concentration is always constant, and it is equal to square of intrinsic carrier concentration. So simply we can write it as N into P is equal to Ni square. For extrinsic semiconductor, out of N and P, based on the material, one will be majority carrier, one will be minority carrier. So if we can write it as majority carrier into minority carrier is nothing but Ni square. Product of majority and minority carriers is nothing but constant, that is equal to Ni square. From this one we can write minority carriers is equal to Ni square by majority carriers, that is Ni square by doping concentration. So minority carriers are inversely proportional to doping concentration. If you increase at that time if you increase the doping concentration, minority carriers reduces. Whenever minority carriers are reducing, at that time to create the channel of previous charge, at that time we have to apply more voltage. Because the minority carriers are less, you must apply more voltage to attract them towards gate side. So you must apply more threshold voltage than previous. So Vt has to be increased. But the statement says threshold voltage decreases with increase in doping concentration. So the given statement is false. We must apply more threshold voltage to get the same charge as previous for increasing doping concentration. So statement 2 is false. Thank you.